So today we are going to introduce you into something called trigonometry. Okay? So trigonometry is split into tri, meaning three, and gonometry, which means the mathematical study of. So trigonometry means the mathematical study of triangles. And we've actually dealt with triangles a lot, but we have not touched upon trigonometry. So when we looked at triangles, we did a lot of work that had to do with the angles inside a triangle. Right? We know they add up to 180. We did interior angles and exterior angles and lots of stuff like that. We also have done lots of things with the side lengths of triangles. But a long time ago, very smart mathematicians realized that there are some pretty amazing relationships between the size of an angle of a triangle and the size of the lengths of the triangle, the sides of the triangle. And trigonometry is really kind of strange when you first see it. Trigonometry. So let's think about a couple things. Let's say I held this length constant and this length constant, and I made that angle bigger. What effect would that have on the triangle?
A big effect. I mean, like, stretch it out.
It was what, stretch what out?
The sides.
The
The,
sides.
which side?
This side.
So I'm saying 3 cannot change and 4 cannot change.
Oh, it affect the bottom. Alright.
5 would get
Bigger.
bigger, right? Now, if 5 gets bigger, what's going to happen to these two angles?
They would
They're going to get smaller.
get smaller, yeah.
So if I call this A, B, and C, if angle A got bigger, then side 5 would get longer and B and C would get shorter. So changing one piece of a triangle is going to change all or some of the rest of the triangle. Right? If I made side 4 shorter, then what's going to happen to angles A and C?
They're gonna get shorter.
If 4 gets smaller,
They're not gonna connect. They can't connect.
well, they'll pull in. So this angle would get smaller,
But that one would get wider.
and then A and C got bigger, right? This angle is larger than that one. So as you draw triangles, there's a really delicate balance between the size of the angles and the size of the sides. And the study of that is called trigonometry. Now, trigonometry applies to all triangles. But in this class, your sophomore year, we're only going to look at right triangles. That's sort of where everybody starts. Okay. So, take really good notes of this, because like I said, this is really strange. So draw this right triangle and label it A, B, and C.
Wait, draw. I thought the side C can't touch the triangle.
Oh, side C. So that's a good point. These are angles. So most of the time when we draw triangles, side A is opposite angle A, and side B is opposite angle B, and side C is opposite angle C. So we usually list angles as capital letters and sides as lowercase letters. And side C does not touch angle C. Does that make sense?
Yeah.
Okay. But that's not going to matter
Oh.
today.
Okay. Sorry.
All right. In a right triangle, we have 2 types of sides. One you already know. So this is called the hypotenuse. Okay. Does anybody know what the other two sides are called? No.
Is it
I
like-
mean, in this case it's base and height, but what if the triangle was turned?
Oh, is it?
No. Those are called, I didn't think you guys would know it, but they're called legs.
Hey, Barbara got it.
So every right triangle has one hypotenuse and two legs. Alright? Okay. And then every right triangle has a 90-degree angle or a right angle. And then the other two angles are called base angles. So A is a base angle and B is a base angle. Okay? Alright, can you remember that?
Yep.
Alright, now draw another triangle.
Like the same one?
Yep, same shape. Okay. In trigonometry, in right triangles, you always have to choose a base angle. You cannot choose the right angle. In big boy trigonometry, you can. But in sophomore trigonometry, where we're just learning the basics, you are not allowed to choose the right angle. So in every single trigonometry problem, you have to pick one of the angles, or a lot of times they'll pick it for you. They'll say use A or use B. Okay? And you cannot use the right angle. Here in a minute you're going to forget that, but I'm reminding you, you cannot choose the right angle. And a lot of times, the base angle we choose, we call it theta. Now, in ancient Greece, they had an alphabet system that's different than our alphabet system. You've heard of most of them. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta,
So actually,
omega,
I've never heard
tau,
any of
rho.
this until.
So fraternities and sororities in college pick three of those letters, like Phi, Kappa, Phi, or Gamma, Beta, Delta, or something like that. Okay? Well, you know a Greek letter. You know the letter pi.
Oh.
That is lowercase pi. In Greek, uppercase pi looks like this. Okay? You also know alpha, uppercase alpha, and uppercase beta. Right? But lowercase alpha you probably haven't seen before. That's lowercase alpha.
I've seen that.
Right?
I've never seen that.
So anyway, another Greek letter is called theta. And lowercase theta is a 0 wearing a belt.
Oh,
Yeah.
so silent.
So that's just a letter. And it's very, very common in trigonometry to choose your angle and call it theta. So over here, I'm going to choose this angle, this base angle, and I'm going to write theta. Now, in this angle, in this triangle, this is the hypotenuse. Okay, that's not up for debate. But the two legs are named according to how they interact with theta. So notice, one of the legs touches theta, and the other leg does not touch theta. Right? So this leg, we use the word for next to. Does anybody know the geometric word for next to?
The fish. He said.
It's not a Greek letter.
Oh.
It's just a word. Beside, so the word we use in geometry is adjacent.
Oh.
So adjacent just means next to. So the leg that touches theta is always called adjacent. And then what's the word for not next to?
Around.
Not adjacent.
Non-adjacent.
We use the word opposite.
Oh.
Gosh dang it, the easy one.
Well, I mean, apparently opposite is the opposite of adjacent.
It's not opposite of adjacent.
So Betty.
It touches it, it's next to adjacent.
I didn't know that.
Oh, so it's adjacent.
I low-key
Adjacent.
don't know how to spell it.
Okay, so in every trig problem, you have to select an angle, and then you have to know the names of all the sides with reference to that angle. So let's draw a different triangle that's oriented in a different way. So draw this and put theta here. And we're super lazy. We don't like writing out opposite and adjacent and hypotenuse. So we just abbreviated A, and H. So in this, where do we put A, where do we put O, and where do we put H?
H on the slant.
H is always the long one. So this is H.
And then the top.
The top is going to be A, and this side is going to be O. HOA, something I hope I never am a part of.
Yes.
What is that again?
Homeowners Association. You pay people so they can tell you you can't put signs in your windows. Yeah.
Yes.
Okay, draw this triangle and put theta over here.
Oh, the hypotenuse is right there.
I can't tell where you're pointing.
This side?
So
This-
which one's the right angle? This one?
Yeah, so it's that one?
No.
So what- This one?
So H is the one that does not touch the right angle.
Yeah, that one.
And then the
A's
one on the
other
left would be
A.
A, and the one on the right would be
No.
O.
Teachers, would you please excuse the girl soccer team?
That's
Okay.
you. I gotta go.
So let's do this,
I don't know how to draw that one.
and let's put theta there.
Theta's the right angle.
So now label A, O, and H.
So H is right. I already told you. H is the right side.
Oh, good. This is a problem, right?
Super mega problem, so move it.
Why is this a problem?
It's on the right angle.
Well, what's
It's
this
the left
one?
angle.
This is H,
Oh,
but
buddy.
it's also
Oh.
O.
That's true.
What?
And what would this be? A, and what would this be?
Hey.
A, and that's a problem.
What?
So remember a few minutes ago when I said you cannot choose the right angle as your theta, and you were gonna forget this. Well, a couple of you didn't. That's why you can't choose the right angle. If you do,
It breaks things.
your O and your H are the same side, and that's gonna be a problem, and you end up with two A's. So never, ever, ever choose the right angle as your theta.
So can we like cross that out to say no?
Yes, this one does not work. Now, next year, there is a way to choose the right angle as theta, but you have to use formulas that we're not going to see this year.
Formulas
Okay.
are
Are you
scary.
gonna be my teacher next year?
I have one class,
How do you spell theta?
THETA. All right. All right, you might want, you're gonna need a little bit of room for this one, so if you need to flip your paper over,
Are we gonna stop recording?
okay? So, we'll put our theta there. All right? So this is opposite, adjacent, and hypotenuse. Okay? Now, in trigonometry, in right triangle trigonometry, we are going to link one angle with two sides. Okay? Now, how many ways are there to pick two sides? We could pick O and H in that order, or H and O, that's two ways. What else could we pick?
A and
A
A and H, H and A,
O and A.
O and A, and A and O. So there are 6 different ways to choose 2 sides. And we need to keep all these separate. We need to know the difference between O and A and O. So what we've done is, we've assigned, what are you playing with? We have assigned names to all 6 of those choices. So O and H has a name. H and O has a name. Okay? The names are strange. And actually, we're only going to learn 3 of the names.
Thank goodness.
We're not, there are 3 more, but we're not going to learn them. So, off to the side, somewhere out of the way, the first name is sign.
Sign?
Yes.
What is it?
Oh, like not actual sign, like sign.
No, it's a different spelling of sign.
This is stupid.
And,
It's like Cindy.
yeah, don't say Cindy. So, I don't know where these names came from. They've been around for a really, really long time. I don't know where they came from. Okay? So another name is cosine.
What about free sign?
No.
No definition to these.
Can you
There
translate
is.
for my
I'll
first
tell you
one?
what they are here in a second.
Hand sign.
And the other one is tangent.
Tangent.
Yeah.
Sine,
that an
cosine,
actual
and tangent.
Yeah.
Is that like an actual word?
Yeah.
What does it mean?
These are all actual words.
Tangent means it touches in one spot. Like if you had a circle and you drew a line that touched it once, that line is tangent to the circle.
Sine, cosine, and tangent is not tangent at all.
Yeah, you're right.
All right, so just for your information, Elise, are you paying attention?
I am actually.
You should probably put that away.
God, fine.
So the other 3 are secant, cosecant, and cotangent, but we're not gonna deal with those.
Cosecant?
Yeah, secant, cosecant, and cotangent. Okay, so now I'm gonna define each of these, and here's where it gets a little strange. Okay? Like I said earlier, we are super lazy as mathematicians, and we abbreviate all over the place. So we always abbreviate trig functions to 3 letters. Okay? And we always abbreviate opposite, adjacent, and hypotenuse as O, A, and H. Okay? So, we're going to make a list
It's showing.
of the sine of theta equals, the cosine of theta equals, and the tangent of theta equals. So write that down.
Okay, 1 second.
It's almost a 20-minute video.
If you have your calculators out, it would be
Yes,
so
you
quick.
will see these abbreviations on your calculator.
Thank you, Kenneth.
Now, here's what you don't do. You do not call them sin, cos, and tan, or people will make fun of you, especially me.
So where are they?
Those are just abbreviations. They're above the numbers.
He's tweaking out his phone.
So
Get a load.
oh, they're right there. Sin, cos, tan.
Sine, cosine, and tangent.
That made me giggle.
I don't need to make fun of Lily. She does a good enough job on her own.
Please.
Okay,
Sorry, what?
so. I said I didn't need to make fun of you. You do that well enough on your own.
Oh.
You right?
Okay, so the sine of theta is the name of choosing the O side and dividing it by the length of the H side. So the sine of theta is O divided by H. Okay? The cosine is A over H. And the tangent is O divided by A. And you probably imagine that the other 3 that we're not going to learn are just the upside down versions of these. H over O, H over A, and A over O. But we don't need to know those. And you don't even have those buttons on your calculator, right? You have a sine, cosine, and tangent button. Because it turns out that's all you need. And in reality, if you had the sine button, that's enough. It's like saying, on your calculator, you really only need the number 1. You don't need all the other numbers, because you can build them using a 1, right?
Yeah.
It would be annoying.
No.
You can.
Okay, so, how does this work? Well, each ratio has a name linked to a particular calculation. All right, girls, you better stop.
Teacher, do you please excuse the volleyball team?
No. All right. You need to memorize this.
Right.
I'm going to give you a stupid, silly, not school appropriate way to memorize this.
Hey, well, I'm recording.
I think you're recording.
Yes.
Don't tell the internet.
So,
Okay.
So,
So what does this mean?
So,
Sine is O over H.
Cosine
is
Above
A
H.
over H. Tangent is O over A.
O over A.
So,
What does that spell?
write down SOHCAHTOA.
Sokotoa.
what is it?
So
Why is it
Katoa.
not school appropriate?
Hey.
You'll see here in a second.
You're scaring me.
Is he so
SOHCAHTOA. That's
I'm
how
not
we
so
memorize.
No.
So, when I was in high school, a teacher taught us SOHCAHTOA and then told us some story about an Indian chief named SOHCAHTOA, and I don't even remember the story. But, later, somebody taught me a way, a non-school appropriate way, to remember this. Okay? You ready?
Whatever you say.
Okay, you'll never forget this. Some old hippie caught another hippie tripping on acid.
That's right.
Well,
Some old hippie caught another hippie tripping on acid.
yep.
SOHCAHTOA. Some old hippie caught another hippie tripping on acid.
That's very not school appropriate.
Not school appropriate. It's a good thing I'm not posting this on YouTube.
But I will.
Okay. So how does this work? All right. I want you to draw this triangle, DEF, 3, 4, 5.
Wait.
Don't worry.
Pause.
Is that what hippies do though? They have lectures on.
I guess so. I don't know. I've never been one. All right.
4, 5, 3.
So, there are lots of things we can do with trig. We're going to start with the very, very basics today. What is the sine of f? Now, there's a lot going on here. So here's what we do. We focus in on f. And then we name all of the sides with reference to f. So what is the 4 in reference to f? What is the name of this side?
The sign?
Cosine.
No, it's
No, no. It's A. Adjacent. And what is the 3 in reference to f?
The O.
This is the O side.
And that's hypotenuse.
And this is the H side. So, the sine of f says take O and divide it by H.
So then you gotta do 3
3
divided by
over 5.
0.6. Which is
0.6.
0.6.
Okay? All right. What is the tangent of f?
So
34.
Right. 3 is the O side. 4 is the A side.
is 0.75.
And then what is the cosine of f? 4/5. So this is actually really easy. It's just kind of strange. It's unlike anything you've ever done before. All right, let me throw you a curveball. What is the cosine of E?
What is the cosine again?
Caught another hippie.
Is it just for?
Tripping on
Oh,
that.
it's 3. Is it 5 over
So when I move this up here, what does that do?
Oh, you have to switch the.
You have to switch the A and the O.
Wait, how does 3 over 4? 3 over 5, my bad.
So the cosine of E is going to be 3 over 5.
You're right.
0.6.
Okay. What about the tangent of D?
Don't you have to like switch the H? No, the H stays.
Shalise, are you paying attention?
I was sad.
So, how about the tangent of D? You can't do it. Why?
Oh, cause
Because there is no
You
D.
can't choose the right angle. Because O and H become the same side and there are 2 A's.
Can you massage my neck?
So the tangent of D is not something we can do in this class. Okay. Let's do a couple more.
Massage your board. It's like really tense.
What is the cosine of B? So look at angle B. Cosine is
Right angle.
B
Yes, there
is
is.
C is a right angle. But
No, A
good.
is-
This only works if there's a right angle,
I have a right angle.
and there is one.
What?
You guys have to remember, he just sucks at drawing.
No, that's
I
a good
don't-
right angle.
Mister.
I take offense at that.
And then judge.
I'm dead.
Let's see. Let's see how good I am.
Oh shoot. Oh. Oh.
So close.
So then I was kind of right. Then there is no right angle in that triangle. So I was not tripping.
All right. So cosine. What are we looking for? A over H. So what is A over H if you're looking at B?
Is it a 5 over 12?
So A over H is going to be 12 over 13.
Okay. Yep. And then. Oh yeah. That
Okay.
would be-
What is the tangent of A?
I don't know. It's O.
So tangent is O over A.
O over A, which is 5 over 13.
No.
Is it right?
So if this is my angle, this is H, this is A.
Oh, it's
this is
12 over
O.
5.
So the tangent of A is 12 fifths.
Which is 2.4.
So, in your assignment today,
Of course it is. And I missed twice.
Why are you rubbing your arm exactly?
So, for your assignment today, you're going to be given a triangle, and it will say, what is the tangent of A? So over here, we circle A,
Yeah.
and tangent is which sides?
The O and A.
O and A.
I don't know which one's O and which one's A. We're so confused.
Adjacent means touches next to,
And then.
and opposite means doesn't touch.
So it doesn't.
So
A
this is
16.
opposite, and this is adjacent, because this one is H.
Are you still recording?
So 30 over 16, and then you just turn that into a decimal.
This is so easy.
Okay? It is pretty easy.
My art.
Now, at the end, it wants to know, so it wants to know what is the sine of 21 degrees. So there's no triangle, but your calculator knows the answer.
Oh, you just have to.
So we just type in the sine of
It's
21.
0.358367.
But there's a catch.
No.
There are actually 3 different ways to measure angles.
Okay.
One is in degrees, one is in radians, which is really weird, and one is in gradients, which that one makes a little bit more sense. So you have to make sure that your calculator is speaking degrees, not some other language. So, up here at the top, you should see a DEG.
Degree.
That's just like
Okay? As long as it says DEG, it will spit out the right answers. So if I changed it to say RAD, and I did the same problem, the sine of 21, I'm going to get a totally different answer.
All right.
you right.
So your calculator has to be in degrees for this to work. And that's the default, so you probably won't need to change it. Okay, that's it.
All right.
Get to work. I gave you a chance. You weren't paying attention.
Bye, guys.